Thank you, Jerry. So welcome everyone to another session of IFD Philly section webinars, winter webinars. So today we have with us JRS. We have Cornelia that will talk to us about insoluble dietary fiber. And to let everyone know, meeting will be recorded and also available to view after that. So please enjoy. And Cornelia, the floor is yours.
Okay, so I'm just going to move the camera now to my other screen so you can kind of see me directly. We had to do it so that we can make the Zoom work. Okay, so good afternoon or good morning, depending on where you are. And thank you everybody for joining this presentation today. And as Zishi mentioned, so today we will be talking about insoluble dietary fiber and how you can use it as an effective tool to develop or improve the quality of a better for you bakery products. Okay, just a second. Okay, so the agenda for today is just to kind of go over the properties of these fibers, and then we'll go into bakery applications. And the first segment
I think we have some technical difficulties.
Yes, this worked out well before. So Cornelia, I think you need to share your screen again. There we go.
You see it now, right? Okay.
Yes, we do.
Okay. So, and then, as I said, a little bit about the agenda. So first we'll go over briefly the properties of these fibers, and then we'll go right into the bakery applications. And the first segment will cover a high level of application, which is for fortification, for calorie and net carbohydrate reduction. And then the last segment will be about the functionality of these fibers in products. So functionality, we don't mean functionality like in our digestion, but basically how these fibers can improve the quality of bakery products. Okay, so a little bit about the company where this stuff comes from. So it's a Joseph Rettemeyer and Son company, JRS company, that's headquartered in Germany. It's an owner-operated family company with over 90 locations worldwide. It's started as a humble wooden grain mill in Germany in 1878 and grew to be to have around 4,000 employees. We have multiple production sites in the world, many sales companies, and 3 R&D locations. One of those is here in the U.S., and actually in U.S. we have 2 locations in Michigan and in Minnesota. If you look at the manufacturing sites, we have multiple manufacturing sites in U.S., which means that many of the fibers that we provide are domestically produced and from domestic raw materials. Okay, so a little bit about the properties of these fibers. FDA defines them as insoluble mixed plant cell wall fibers. What does it mean? It means that they originate from plant cell walls, and their main components are cellulose, lignin, and hemicellulose. They are very high in total dietary fiber, which makes them quite convenient for fortification projects. They come from various plant sources, and usually these are byproducts of the food industry or agriculture. According to FDA, the physiological benefit is increased fecal and bowel laxation. However, we have run studies that show that they also attenuate blood glucose and insulin levels, and there is also proof of slow fermentation in colon. Now, there are many of these fibers, and sometimes when you look at them the first time, you think, well, many of them look the same, but they're actually quite different. And each fiber in its application is defined by its chemical composition, then water and oil holding capacity, particle size distribution, particle shape, texture, mouthfeel, and at the end, color. So when we choose fiber for certain application, we take all these characteristics into account to decide which fiber we want to use. So this is just to go very briefly without going deep into the whole technology. It's of course it's those are proprietary processes that we use, and by using these processes, we isolate fiber from the plant cell walls. I want to stress out that the fiber is not modified. It comes out from these raw materials and it stays the way how it is in the plant. This increases the absorption ability of the fiber, and also more importantly, it allows us to obtain fibers with very different characteristics and therefore very different purposes and functionalities in food products. This is just a quick overview of all the fibers and other ingredients that we have. By far, the dietary fibers, they make the largest family of products. Functional systems, these are various hydrocolloids, and we also put some citrus fiber under here. And then we have specialty products, and for everybody who is in baking, then the stabilized germs and brands are of interest. Here's a quick example. This is our family of oat fibers. There are actually more of them, and then on the right-hand side, you can see all these various applications, and we'll go into it in some following slides. Okay, so then it lends the question, like, just really how different they can be, right? Because they all come from oat hulls. So how different these fibers can be. So for all of us who are involved in baking projects, we know farinograph, right, as a standard instrument in mills and bakeries. And we also use it to test our fibers. This is a high fiber dough model here that has 20% bakers of fiber, and it also has gluten and flour. And you can see a huge difference between two oat fibers. Same raw material, very, very, very different products. This one is the one that we would recommend for high fiber fortification. Obviously, it gives a very nice stable curve. This is definitely not something that would go for fortification, but this fiber is highly functional and we use it for other purposes. Properties. So these fibers are very process tolerant, so you don't have to worry about them being maybe, used up by yeast or breaking down due to heat. They are heat stable, extrusion and shear stable, freeze-thaw stable, and pH stable. They hydrate very quickly. They do not cause gastric distress. Oftentimes, they are at lower cost than soluble fibers. And if you're really looking at making a better for you bakery product, then you want this to have 0 calories and also non-digestible carbs, which these fibers have. Most of them are clean label, they are non-allergenic, and they are not produced from genetically modified plants. Okay, so when we talk about fiber, right, it's inevitable we have to mention digestive health. And there are many articles out there. People read about it on the internet, right? And more consumers are becoming more and more aware of it, and they want food products to be good for their digestive health. However, all this stuff here is involved in digestive health. So this kind of can be a little bit confusing. So how do we make sense out of it so that at the end we don't resort to this kind of diet? Because nobody really wants to have a lettuce shake, right? So this is the situation here, right? According to American Dietetic Association, really the best thing is to eat a diet that has a balance of fibers, insoluble and soluble fiber. This would be your nature-given ratio of fibers. So they say if you eat a diet that's based on whole foods, which means not whole grains, nuts, seeds, fruits, vegetables, they provide approximately 2/3 to 3/4 of insoluble fiber and 1/3 to 1/4 soluble fiber. So you basically need both in your diet. Now, I intentionally put it in capital letters that insoluble fiber can be used to formulate for digestive health. I hear quite often that usually prebiotic fiber is considered to be the one that you need to use for digestive health. It does not have to be just prebiotic. Insoluble fibers can also be used to formulate for digestive health. FDA does not regulate this. So, from digestive health, from insoluble fiber, you get these benefits. It's maintenance of regularity, slow fermentation in colon, improvement of insulin sensitivity. So these are the fibers that we had actually run tests and studies that prove it. They also do not have negative GI effects, so there is no gas or bloating. And they are also FODMAP friendly. So other than apple fiber, it has some fructose in it. So if you're formulating low FODMAP foods, you can use these insoluble fibers to do that. Okay, so now after bakery applications, and so here we are going to review 3 formulations. We of course have many more different types of products. So if you are interested in anything else, just feel free to contact us and we can always share that information. Here we are talking about fiber fortification, calorie reduction, and then low net carb products. So, 2 main reasons why we would use these fibers in bakery products. One is nutrition, the other one is functionality of a fiber. When we talk about nutrition, these are high application levels. We can go over 20% bakers with these fibers. They are used for fiber fortification, calorie and net carb reduction, even for sugar reduction. This is, of course, work in progress, but we know it's coming for us. And overall, make better for you products. When we talk about functionality, these are low application levels. And here we would use fiber to improve the structure of your product, to improve the strength and flexibility of low moisture products and reduce breakage. Also to modify the texture, to improve the mouthfeel of gluten-free products, improve crumb resilience and springiness. You can bump up the dough yield because fiber absorbs water, and you can also slow down staling. So let's look at first the nutrition part of fiber. So here's an example of a product that can be considered better for you product. It basically produces 10 grams of fiber in one roll, and seasonal because it was developed in winter, so it has a little bit of apple flavor and some of the spices, and it has a lot of whole grains. So this formula basically shows that the fibers, they complement whole grains, right? People like whole grains, they are good for you, but whole grains do not really lend that much fiber as fiber products do. So if you look at it, this is a clean label product, something that consumers like, and it has 2 fibers in it. Apple fiber, it provides that pleasant, mild apple flavor. And it also provides some sweetness that's not labeled as added sugar. Oat fiber 358, on the other hand, is a fiber that is light, it's soft, it has moderate water absorption, so it's one of the main fibers for fortification. So this is the output. You get 10 grams of fiber, 28 grams whole grains. We get 8 grams of protein. We did not intentionally add protein, but it basically comes from gluten and then from whatever grains bring in and flour. We get 0.6 gram sugar from apple fiber and only 1 gram total sugar because, as if you can see here, we replace sugar with allulose. Now we know allulose has bulking properties, but fiber does too. So if you are looking at sugar reduction, these fibers have bulking properties, so they can help with that. And most importantly, this is for a consumer who is looking for some health benefits from the bakery product, but doesn't want to go to extreme and use keto products. Better for you snack. This is I call it like a snack of the future, and this is really how they look, like little puffy pillows. The reason we focused on snack is because healthy snacking is one of the leading current trends in food. And according to some data, nearly 3 in 4 Americans snack at least once a day, and more than half of Americans replace traditional meals by snacking. However, the problem with snack is that you eat 1 ounce of snack and then immediately the guilt will kick in, because on average it has around 120 calories and it doesn't really provide that much fiber. So our idea was to develop this better for you snack that's for people who still want to snack. They don't want to compromise on texture and flavor. They want the product to be indulgent, but at the same time, it has to have lower calories and it has to have more fiber in it. And then I have to mention it's baked, it's not fried. So we ended up with a snack that has only 60 calories per serving, per 28 gram serving. It has 15 grams of fiber, and then it only 5 grams of net carbs. So this is the formula. As you can see, there is no wheat flour here. We use some other flours, mainly chickpea flour, sorghum, potato flakes, and then we loaded it up on fiber. So it has also resistant starch and soluble corn fiber, and then 4 of JRS fibers. So it was really interesting how they all played a nice role in this product. So a combination of bamboo and oat fiber here, these two, they contribute 50% of fiber in this product. And these two fibers, they have the right balance of texture, water absorption, and fiber content. So that's how we basically combine them together. To be soft, not to have too high absorption because it will be hard to bake it out. And of course, they contribute 0 calories. Oat fiber HF 200, that's a fiber that's used for to add strength to your product and to reduce breakage. It's a very soft, long, very flexible fiber. And so when you use this fiber in a product, it basically builds a network of long fibers. And those long fibers, they allow the product to absorb more stress before it breaks. And so that was the idea to use it here because this is a product that's very thin, so it can easily break. And then we also use our psyllium P95, and the reason for that was that it provided some binding function because we really don't have gluten in this product. So that's how we made this snack. And then, if you're interested, we can always send out some samples, but it it really tastes like it doesn't really have all these fibers in it, because usually people think like, well, it's loaded with fiber. It probably doesn't have such a good texture, but it actually does. And then at the end, keto-friendly tortilla. So we know like tortillas are very popular these days, and they're very convenient. And there are multiple keto tortillas out there in the market. What we wanted to do here is to make a keto-friendly tortilla that has a nice balance of fibers so that we can improve the mouthfeel of it. So to break up the starchiness, yet not to really make it kind of gritty. So we wanted to make a tortilla that has a texture and mouthfeel that's as close to conventional wheat tortilla as possible. And so for that, again, we use this fiber. You can use either a powdered cellulose FL611 or an oat fiber 550. These are soft fibers, medium absorption. So those are usually the fibers that you would use for high fortification levels, and they're also light color. Most importantly, they really produce a nice texture in this tortilla. And then we also use, again, oat fiber 200, that long, soft, flexible fiber, because what it did, it allowed us to have a tortilla that after 4 months still looks like this. This is 4 months shelf life at room temperature. You roll it, you fold it, and it's not cracking. And then at the end, citrus fiber, that's a very unique fiber because it's a combination soluble and insoluble. And citrus allowed us to improve the product resilience. It also contributed to this, that we can easily fold it, roll it. And it also showed to be good to maintain the shelf life. It slows down the staling. So this is what we got at the end. 60 calories in 43 gram serving, only 1 gram of net carbs, and 15 grams of fiber. So you don't really feel guilty eating this tortilla, but at the same time, you don't suffer through eating it because it has a pretty nice texture and also flavor. These fibers have very neutral flavor. So that's on fiber fortification. And so let's see now a little bit about the fiber functionality. This is quite interesting. When I started working some 18 years ago with fiber, I it was hard to convince me that fiber can do that stuff. And then my coworker who worked a lot on low moisture products, he showed me, and it's really quite impressive to see. Not because we make it, but it's really kind of nice how these fibers can do some troubleshooting for you in products. So let's start with citrus fiber. So this is a new kid on the block for us. It's one of our newer products. It is highly, highly functional fiber, which means you're never going to use it for fortification, mostly because it has really high water holding capacity, but you're using it for functionality. One thing I have to emphasize, it does not have any citrusy, any burnt flavor, and it's a light beige color. So it contributes no flavor to your product. It's a part soluble, part insoluble. The soluble part is pectin, and this is what actually lends it its specific functionality in products. It's used at low level, and consumers like to see citrus fiber on labels. It's upcycled, it's non-allergenic, and it's a clean label. It just looks good on label. But besides looking good, it also works good. We tested it in our keto muffins. So we have this formula. If anybody is interested, we can share. The original formula was made with zero point 0.2 xanthan and zero point 0.2 guar gum. And then we decided to take these gums out and see what citrus fiber will do. Now, naturally, you cannot use such low level of citrus fiber like gums. But if you're formulating a product that has to be clean label, that targets consumers who want to see recognizable ingredients on a label, then citrus fiber is a good option. We made these muffins, kept them 9 days at room temperature in those clamshells, and then threw them under texture analyzer. And what we measured is how much the firmness will increase from day 1 to day 9. So these are relative numbers, right? This is percent increase. And what we noticed is that the citrus fiber outperformed a combination of these two hydrocolloids by approximately 4%. So 4% lower increase in firmness was quite interesting. A springiness decrease was pretty much the same. And when you eat these muffins, the ones that are made with citrus fiber, remember I mentioned they impart some resilience to crumb. That's what you feel when you eat it. Like there's just a more bite to the muffins that are made with citrus fiber. They also work in breadcrumb. We know that our Vitasel P95 psyllium product works well in slowing down staling, and it's a hydrocolloid, so it does its job as hydrocolloid. So we used citrus and psyllium at 1% based on flour, and then let them sit in bags for 14 days, and then measure the firmness of the crumb. And you can see that with citrus fiber, actually the crumb was staling slower than with P95. So overall, it's a nice clean label tool to manage the product of the shelf life. And of course, you can use it in combination with anti-staling enzymes. So now I want to talk a little bit about the low moisture products. So with low moisture products and what fiber does in them, they're really very much in a league of their own. We know that one thing that all low moisture products have in common is that they break. And they have checking, they have cracking, and then eventually they can break. So if you remember earlier, I mentioned HF200, right? That long, soft, flexible fiber. So that's the one that helps us to reduce these negative things in low moisture products. So if you add some of that HF200, it will increase the strength of the product. And so that product will be able to absorb more stress. It will flex more under the stress. So you really have to apply more force to that product before it breaks. And so it really helps when you are transporting the products, or when it's handled in a store, or when it's handled by consumer at home. Now that's one functionality of fiber. The other one is texture modification. So texture modification, effect of fiber on texture modification is even bigger in these low moisture products than, for example, in bread or cakes, medium moisture products. Here it really shines. And how does it work? Unfortunately, in a presentation, you cannot taste them. But if you use a fiber that has high lignin and it's a long fiber, you get more crunchiness. If you use something that has medium lignin content, well, it will have minimal effect on texture. If you want a cracker that's chewier, that's tougher, you can use low lignin products. If you want a cracker that's more friable, you can use fiber with small particle size. It's quite interesting. Now, breakage reduction, right? That's a headache for every manufacturer of these low moisture products. And we have done several tests to see, how fiber can help with this stuff. So pretzel rods were made in a manufacturing plant, and then they were shipped. So basically, they went through the same process, that they do every day when they leave the plant. And then we measured the peak force that's needed to break this pretzel rod that has fiber in it. And you can see that it did improve the strength of the pretzel rod. This is a fiber that is used quite a bit commercially these days for various low moisture products out there. Here we had saltines. Also, we tested two different fibers. These are two different oat fibers at 3% based on flour. And I call it a very sophisticated test in quotation marks. We basically take those and drop them down from like a 3 feet height, which realistically can happen in stores. We drop them sometimes at home. And so these are real life situations. And we see that both oat fibers reduce the breakage, but HF200, that long soft fiber, was by far most effective. Speaking of other low moisture products, cookies. Same like in fibers, like in crackers. Fibers can modify the texture of the cookie, which is interesting. Like you want to get, you have a recipe and you want to get cookie A and cookie B with different texture. You put two different fibers in it, and you're going to get basically two different cookies. These are some of the functionalities of fiber and the levels that we use. But I want to point out that this one, we can combine a couple of fibers to achieve two different functionalities in the same cookie. So we can use HF200 to reduce breakage, and then we can use HF200 150 to increase the crunchiness of the product. Although they look very similar, but these are two very different fibers. So just keep that in mind. The one that has dash 150, it's a coarse fiber, and it helps to increase the crunchiness. So two things at the same time. So my coworker had made these sugar snaps and with different fibers. And you see here 200, 150, when these were subjected to some sensory analysis, it had more like snap and crunchiness, whereas the one with HF200 had a tougher bite. But at the same time, this is the one that's least likely to crack and break. Another functionality of fiber in cookies is to reduce the spread. And it's actually a pretty simple mechanism, right? So fiber absorbs both oil and water. And so when that fat starts melting in a cookie, fiber will grab it. So the fat will not be so available to spread the cookie. So it's a pretty simple mechanism. However, different fibers work different way, right? So this is kind of a little hockey puck compared to this one. And so really fibers that have higher absorption ability will definitely restrict the spread more. So that's an interesting application. If a manufacturer has a problem that the cookies are spreading too much and you can't really put them in packaging, for example, then fiber, a small amount of fiber can help with that. So a little bit about the gluten-free products, right? So gluten-free products have come a long way. since I tasted them first time many years ago. And nowadays we have some really nice gluten-free products in the market. But they all suffer from the same thing, that the nutritional value is not that good because they really don't have a fiber in them. They're all starch based. And also you still have a little bit of that starchy mouthfeel. So fiber can be used to break up that starchy mouthfeel. So here we use the powdered cellulose 611 100. It's a works even at lower level. Here we added this amount because we also wanted good source of fiber in this muffin. But even at the lower level, it could be like, let's say 4% based on flour. Uh, you're going to drastically improve the texture. And the way it works is that, as I said, it breaks up that starchiness, and it also improves the resilience and the bite. So when you bite into that muffin, um, you will feel that it has a texture and a mouthfeel more similar to conventional muffin. Then here we also use psyllium P95 because it's a gelling fiber, so it helps to build structure. And also it improves moisture retention for the shelf life, right? This is a hydrocolloid. And then the major player is hydroxypropyl metal cellulose. It's a surface active material that has the ability to stabilize the gas cells. And this is important because we have no gluten in the system. Also, it will gel during baking, and that helps to suspend the chocolate chips. Once the product cools down, comes out of the oven and cools down, that gel converts back into a liquid, and now it also helps with the moisture retention and helps with the shelf life. When these muffins were tested, were sensory testing done with these muffins, we compared our gluten-free muffin with a standard that did not have these three ingredients, and also just with a conventional muffin. So if you look at the green line, that's the JRS gluten-free muffin, you can see that the integrity of the product was improved, right? So we had psyllium, we had HBMC there. The dryness was reduced, the crumbliness was reduced, and also the pastiness. This is where that cellulosic fiber played a role to reduce the pastiness. So this is pretty much our solution for gluten-free. You know, you don't have to use fiber maybe all the time, but these three components, they work together really well. So a little bit about oil absorption in donuts, right? So we are looking at better for you products these days, right? We want to reduce calories, we want to reduce sugar, we want to reduce fat. And so my coworker ran this test here. We had a commercial donut mix and then added 3% fiber to it on dry basis. And so we had control without fiber. And then we have two tests with oat fiber. And then this, sorry, I didn't really spell it out. This is a sugarcane fiber. And these are two fibers that are on lower absorbing end, which is good because they're not really going to change the viscosity of the batter too much. So these were like the donut prints, I call them, and the difference is quite striking. So we wanted to see what really happened here. And then these donuts were sent out to independent lab for a nutritional analysis. And the focus was, of course, on how much fat was absorbed in those donuts. So if you focus on sugarcane fiber here, you see that it drastically reduced the amount of fat that was absorbed in a donut. And the total fat content, I mean, it drastically increased the reduction of the fat, right? The amount of fat was lower than in control and other fiber donut. And also the moisture level was higher. So we postulated here, you know, since fibers, they absorb both water and moisture, but by far they have higher affinity for water, right? Than excuse me, it's not water and moisture, water and fat or oil, but they have higher affinity for water. So basically, this donut batter will grab water, and then it will reduce the excess of oil. So basically, the fiber grabs water, and right, water and oil don't mix, and it will actually reduce the amount of absorbed fat. So we are still working on this project, but we know that, well, everybody loves donuts, right? It's hard to give up donuts, but if we can kind of make them a little bit less caloric, that would be nice. So fiber can help with it. And then for the end, sorry, I'm going a little bit over time. For the end, I love the topic that is a kind of a painful topic for us in bakeries right now. It's a topic that keeps coming back, and it's replacement or reduction of eggs. And so JRS, we do not provide a whole blend to replace eggs, but we provide individual ingredients that are quite effective in products where you need to replace or to reduce eggs. This was a case study where we had to replace egg whites. HPMC works well as an egg white replacement, and it's able to stabilize air cells. It's a surface active material. And if you use a right combination of HPMCs, you can actually have that gas stabilization effect throughout baking. So here we use this one HPMC blend. It was blended with the whey protein concentrate. So the requirement here was not plant-based. So it was blended with whey protein concentrate, and that blend was added to muffins in 1.75 or 2%. And you can see the effect. Actually, the one with 2%, to me, it looks even nicer than the control. And it's nicely suspended the blueberries in it too. So generally, this is a little overview of our egg white replacement strategy, right? So the main player is the hydroxypropyl methyl cellulose, and then you blend it with a protein. Now, either it's an animal protein, or if it has to be plant-based product, then a plant-based protein. We do not supply the proteins, but you can always source it from other suppliers. Of course, now replacing a whole egg is a little bit more challenging. So our approach is we need to add some emulsifier to it, right? We need to put that back. So far we've just gone with lecithin, and other approaches are probably out there too. But this is basically how we approach this problem of egg shortage these days. So that's all I had for today. So thank you for your attention. I know I dumped a lot of information on you in a short time. If you have any questions, feel free to ask, and we can also connect later. If you will have some questions after you review the slides, or if you are interested in any other applications that we have with fiber. Okay.
Yep, thank you so much for the presentation. I think it was really interesting.
Thank you.
Touch really all the different areas what fibers can do
Mm-hmm.
from gut health through egg reduction. So that was yeah, very informative.
Thank you.
Does anyone have any questions? We have one in the chat.
Okay.
How can we access the recorded presentation later or share it? So we do have Jerry is actually amazing. She made a YouTube channel where we will share all the recording following that. It should be up in the next day or two.
Mm-hmm.
So if you search on the YouTube IFT Philly channel, you should find a recording for today's presentation in a few days, but also look through the past ones.
Mm-hmm. Yeah. Yes. And then if you have questions after, if you want to review the presentation and you have any questions after that, then just feel free to reach out to us. Yeah. If you have any questions, don't be shy.
Yep, Gabrielle in the chat has a question.
Okay.
Do you recommend the use of citric fiber for a jam?
For a jam?
Mm-hmm.
Yeah, it can be used. I don't specifically work with those products. Some of my coworkers do. So if there is any question about that, then I can always connect her with my coworkers to discuss that topic. Yeah.
Yeah, so great. I'll suggest to Gabriel if you can connect with Cornelicia or someone
Yeah.
else from JRS, they should be able to
Sure.
answer the question. Another question in the chat from SP, how does using long fibers contributes to crunchiness of product? Any insight on fiber length? I think we lost Cornelicia, but I think she should be back shortly.
Yes. So she still has her other screen on, so she should be coming back shortly.
I just messaged her
Oh,
to make sure she's still on.
okay. Just was doing the same thing. Okay, thank
Yeah.
you. Hmm.
Yeah, we have 3 questions.
I think we also have other. Oh, no, not yet. Cornelia
Oh,
just
she
joined us.
joined. Hmm. Yeah, let's see, she's back. Hi, Cornelicia. I think you're muted.
Okay.
Yep,
So
we can hear you now.
I don't know if can you hear me now?
Yes, we can hear you now.
Okay, so sorry, I just hopped on from my phone. I don't know what happened. Did anybody else got locked
Yes.
out?
Yeah, so we have a few more questions that came in. One of them was how
Oh,
does using long fibers contributes to the crunchiness of product? And if you had any insight on the length of the fibers.
yes. So it's not just the length of the fiber, but it's also the texture of the fiber. So the texture of the fiber is important. Um, the long fiber helps. So let's say about 150 microns, but the texture, it has to be a coarse fiber, a coarser fiber that has higher lignin content in it, because lignin is the crunchy component of the fiber. So you want the combination of those two to achieve crunchiness.
Thank you. So that's great. So lignin content and also the texture of the fiber would provide the crunchiness.
Yes.
And Tiong had a question for clarification. JRS offers unmodified cellulose powder. So does JRS offers unmodified cellulose powder, and how does the unmodified cellulose behave versus the modified one?
So the modified cellulose would be your hydroxypropyl metal cellulose, right? Or metal cellulose. So this is where your cellulose actually starts acting like a, let's say like a hydrocolloid, right? So these are modified, chemically modified. These are standard products that have been around for a while. Unmodified, that's just a plain cellulose. So basically, it's isolated from the plant source, let's say from oat hulls, but we do not do anything with it after that. We just basically dry it and grind it. So that way we are concentrating in the fiber in that product. We are concentrating in the cellulose, but we are not really doing anything else to it after that. So it's as it is in nature, basically. Yeah.
Thank you. And I see a last question. Gabriel asked again, for replacing eggs, what do you think? If we can use it, can we use it in a sponge cake? And follow-up question would be, would a combination of milk, protein, and HPMC likely be something that would work well for replacing eggs.
Yes, yes, because we don't provide a protein component, so you have to substitute it with something, right? In egg replacement. So yeah, so you can use some type of a milk protein. In this case, we use the concentrate, the whey protein concentrate. So you have to decide which protein source works best for you. But generally, dairy proteins they work well, and then in combination with HPMC. Yeah.
Yeah, so short answer, I think it would work on sponge cake. It just depend on how much you
Yes.
supply it for. Yeah, amazing. I think that was the last question. Any other one has additional questions? If not,
Mhm.
yeah, I think let's thank Cornelia for an
Thank
amazing
you.
presentation. And if you guys have anything else to add, feel free to reach out to any JRS representative. And
Sure.
again,
Sure.
thank you for attending the webinar, and thank you so much, Cornelia. It was
Well, thank
amazing.
you, and yeah, thank you for giving us an opportunity to present about our fibers that we love them dearly. And so, yeah, are you sharing the email with attendees? So I don't know if people can have my email to be able to contact later, or how do we do that?
Yeah, we'll be happy to maybe write in the description on under the
Mhm.
video your contact information.
Yeah.
So yeah, that can be done.
Yeah, so they can reach out. Yes.
Yeah, for sure.
We may not have an answer for everything, but we that's interesting with fiber. After 18 years, you think you've seen like just about everything, and then
Yeah,
things keep popping up. So which is really good, but we will make effort every time to find a solution. So even if we don't have it right now.
yeah, that's great news. That suggests
Mhm.
that there is always innovation in the
Yes.
pipeline.
Yes, there is. Yeah, well, I appreciate it, and thank you everybody for joining us today. So it was a privilege to be able to present.
Thank you so much.
Thank you
Thank
very
you.
much.
Thank
Have a
you.
great day.
Bye.
Yeah, good information.
Thank you so much, and we'll end this now.
Thank you.
Thank you.